Hello everyone, my name is Emil Hadziev and today I will talk about the cache memory. Let's start. Cache memory is a chip-based computer component that makes retrieving data from the computer's memory more efficient. It's a temporary storage area from which the computer's processor can retrieve data easily. Cache memory is sometimes called CPU memory because it's typically integrated directly into the CPU chip or placed on a separate chip that has a separate bus interconnect with the CPU. Therefore, it's more accessible to the processor and able to increase efficiency because it's physically close to the processor. Main advantages of cache memory is that it's faster in comparison to main memory and secondary memory. Programs stored by cache memory can be executed in less time. Additionally, the data access time of cache memory is less than that of the main memory. And also, cache memory stored data in instructions that are regularly used by the CPU. Therefore, it increases the performance of the CPU. Disadvantages is that cache memory is costlier than primary memory and secondary memory. The high cost of cache memory increases the price of the computer system. Also, data is stored on a temporary basis in cache memory. Traditionally, cache memory is categorized as levels that describe its closeness and accessibility to the microprocessor. There are three general cache levels. Level 1 cache or primary cache is extremely fast but relatively small and is usually embedded in the processor chip as a CPU cache. Level 2 cache or secondary cache often has more capacity than level 1. Level 2 cache may be embedded on the CPU, or it can be on a separate chip or coprocessor and have a high-speed alternative system bus connecting to the cache and CPU. That way it doesn't get slowed by traffic on the main system bus. Level 3 cache is specialized memory developed to improve the performance of level 1 and level 2. Level 1 or level 2 can be significantly faster than level 3, though level 3 is usually double the speed of the DRAM. DRAM is dynamic random access memory. With multi-core processors, each core can have a dedicated level 1 and level 2 cache, but they can share a level 3 cache. If a level 3 cache references an instruction, it's usually elevated to a higher level of cache. How data is transferred? When a read request is received from the processor, the contents of a block of memory words containing the location specified are transferred into the cache. Subsequently, when the program references any of the locations in this block, the desired contents are read directly from the cache. Usually, the cache memory can store a reasonable number of blocks at any given time, but this number is small compared to the total numbers of blocks in the main memory. The correspondence between the main memory blocks and those in the cache is specified by a mapping function. When the cache is full and a memory word that is not in the cache is referenced, the cache control hardware must decide which block should be removed to create space for the new block that contains the referenced word. The collection of rules for making the decision constitutes the replacement algorithm. Replacement algorithm chooses within the constraints of the mapping function which block to replace when a new block is to be loaded into the cache, and the cache already has all loads filled with other blocks. One strategy is to replace the block that has been in the cache longest with no reference to it. This policy is referred to as the least recently used algorithm. In conclusion, cache memory serves as a critical component in computer systems, enhancing performance by reducing memory access latency. Despite its limitations, such as limited capacity and cache coherence challenges, cache memory remains indispensable for achieving efficient and high-performance computing. Its role in bridging the gap between the CPU and main memory is instrumental in optimizing system responsiveness and overall efficiency. This is the references of my presentation, and thank you for watching.